Welcome everyone. In this video lecture, we will solve a microelectronics circuit problem, which is basically on diode-based problem. So the question is, assuming that the diodes in the below circuits are ideal. So there are two circuits, figure A, we can say, or question number A or question number B. Okay, and the diodes which are used are ideal. So utilize the Thevenin theorem to simplify the circuit and find the values of level I, the current, and voltage. We have to find the value of I and V in this circuit. So this one is the circuit. So this is 9 volt, 10 kilo ohm, 10 kilo ohm, 20 kilo ohm resistance, 20 kilo voltage, and I we have to find. So in such situation, first of all, we have to redraw the circuit. For this purpose, we have to use the Thevenin equivalent concept. So what I am doing, first I am just making this part. So I am just writing this as a 9 volt. Okay, okay, and this one is a 10 kilo. Okay, I'm writing this as a 9 volt, and this is a 10 kilo ohm resistance. Okay, and this will be our 20 kilo ohm resistance. Okay, we are just redrawing the circuit. Okay, first see how we are redrawing the circuit. This one is the, and this should be our 20 kilo ohm, and this one is our V, and we have to think about this current I. So this one is the, we have redraw the circuit. This portion, okay, this portion we have redrawn like this. Okay, this yellow portion we can rewrite 9 volt, 10 kilo ohm. Okay, then this one is 20 kilo ohm resistance, and this one is very simple. Okay, now we have to utilize the concept of Thevenin equivalent. So if this one is, this part is the circuit, so one can see a Thevenin equivalent of voltage VTH. Okay, from that side will be our 9 volt. Just apply the voltage divider rule. 9 volt into 20 kilo ohm by 20k plus 10k, or we can simply write 9 into 20. Kilo will be cancelled out, so it should be 30. So it should be this 0 will be cancelled, then this should be 3. There will be 6 volt. And the R Thevenin, the equivalent resistance. Okay, for the equivalent resistance or Thevenin resistance, R Thevenin, we have to make it short. Okay, this supply will be source, will be sorted. So basically better to write from this side, better to write from this side. Okay, R Thevenin. Okay, so for R Thevenin, we have to make this one as a voltage. This voltage source will be grounded. So this R Thevenin will be simply our 10 kilo ohm parallel with this one, and these two resistors will be in parallel. So we can write it 10 into 20 by 10 plus 20, R1 into R2 by R1 plus R2. So 200 by 30. So it should be simply 20 by 3. Okay, and it should be kilo ohm. Very simple calculation is there. So now again we are redrawing the same circuit. Okay, by just writing the Thevenin equivalent, and okay, and there will be some resistance R Thevenin, R Thevenin, and there will be some diode. Okay, and then this will be the, okay. So basically this was our VThevenin is 6 volt, and this RThevenin, that is our 20 by 3, and this one will be our just 20 kilo ohm, and this one is volt, and this one is some current is flowing I. So this I current will be flow in this circuit. Okay, so now it is very clear that this diode is the ideal diode. Okay, so for ideal diode we can make this as a short circuit. Okay, and then after we have to just apply Kirchhoff's voltage law in this loop, say loop 1. Okay, Kirchhoff's voltage law in this loop. Okay, so one can easily write the equations for that, which is simply our, we can write the equation by utilizing VTH minus some current is flowing in the circuit, so I into RTH. We can use any uh, convention. Okay, I am writing minus I RTH. This will be 0 because this one is sorted, so no need to worry. And then minus 20 into 10 to the power 3. Okay, equals to 0. This current I into 20. Okay, so now here it is very clear. VThevenin is 6 volt minus RThevenin is okay 20 by 3 kilo ohm. Okay, 3 kilo ohm. So we can write it 10 to the 3 into I will be I minus I into 10 to the 3, or one can simply write, if we make it simple, we put all the thing in the right hand side, 10 to the 3 I 20 by 3 plus 20. Okay, now we have to solve this one. So what we can do, this 6 equals to 10 to the power 3 I, one can also take common 20, then 1 by 3 plus 1. Okay, or one can write 6 into 10 to the power 3 I, simple calculation 20, directly writing 3 plus 1 4 by 3. Okay, so I am writing here the current value I equals to 6 into 3. Okay, by 80, 6 into 3 by 80. Okay, and this will be in below, so it should be 10 power 3. Okay, so one can also solve like this, 3 by 40. Okay, so it should be around 9 by 40, and 10 to the 3 means 10 to the minus 3, so it should be 9 by 40. So if we calculate 9 by 40, it will come around 0.2225, and this should be milliampere. So from this one we can easily find the current expression, that is our I in the circuit, 0.225 milliampere. Okay, the current which is flowing in this one will be this, I will be this. So now we have to find the V. So for the V value we can simply multiply I into R. I into R, this R, that is our I into 20 kilo ohm. Okay, so I am writing here because I have a space here. So I is nothing but simply 9 by 40. 9 by 40 into 10 to the power minus 3. Okay, and R value is 20k. So 20 into 10 to the power 3. So this should be cancelled out. This should be 2. So it should be simply 9 by 2. So V value will be 4.5 volt. So V value will be 4.5 volt. So the answer will be, the voltage will be 4.5 volt. I will be 0.25, which is calculated here. Okay. So the level voltage, that is our this V, and directly writing will be 4.5 volt. This voltage will be 4.5 volt, and I value, which we have already calculated, this I. Okay, I will this one. So this is a simple one, but we have used the concept of uh, Thevenin equivalent. Okay, so this one is the first problem where we have find the level voltage and current in the circuit. Now we have to go for the second one. So second one, this one is the problem. So once again we have to redraw the circuit. Okay, so what we can do, okay, this one is basically our 9 volt. Okay, then this should be our 10 kilo ohm, and this should be our also 10 kilo ohm resistance. This one is a diode. Okay, it is very simple, 10 kilo ohm resistance, and then again this 10 kilo ohm will become here. Okay, and this will be our 5 volt. Okay, and this voltage is plus V, and some current is going like this. Okay, so basically once again I am redrawing, I'm just showing this green portion will be this. Okay, and this portion, yellow portion will be this. Okay, so this we have made, and this one will be common. So this one is the circuit. Okay, so now next thing is that we have to find the VThevenin for this one, for VThevenin. Okay, so it will better to do like this. VThevenin here. Okay, I'm writing as VThevenin 1. So it should be 9 into 10 kilo, just voltage divider rule, right? 10 plus 10, simple. Means if this one is some VCC R1 R2, so this VThevenin equals to VCC into R2 by R1 plus R2. So it should be our 90 by 20. So it should be our 9 by 2, that is our 4.5 volts. So this value 4.5 volts. Now next we have to find the equivalent RThevenin. So RThevenin, R1 parallel with R2. These two resistors will be in parallel by keeping this one as a short. So this value will be, both are having the same resistance, 10 kilo ohm parallel with 10 kilo ohm. So it should be 10 into 10 by 10 plus 10. So it should be 20, oh sorry, 100 by 20. So this one will be 5 kilo ohm. Okay, this part is over. Now we have to focus about this one. See, I am saying this part is VTH2. So again what we okay, uh, I'm writing like this. Okay, this one is say VTH2. Okay, so will be 5 into 10 by 10 plus 10, so 50 by 20, so 5 by 2, that is our 2.5 volt. Very simple. Okay, now again we have to do it for RThevenin. Okay, RTH2. Okay, say this was TH1, TH2, anything. Okay, so just 10 kilo ohm will be in parallel with 10 kilo ohm. So R1, R2 having the same value. So R by 2. Okay, so it should be 5 kilo ohm here also. If we solve, very simple calculation is there, 5 kilo ohm. So again, now we have already done the RThevenin, VThevenin. Okay, so we can now, we have to redraw the circuit. Okay, say I am saying this one is RTH1, VTH1, and this one is grounded. Okay, and this one is the diode RTH2, and this one is our VTH2. Okay, now just put the value. Say this one is RVTH1, 4.5 volt, RTH1 5 kilo ohm, this one is also 5 kilo ohm, and this one is 2.5 volt. Okay, so this side will be more negative than this one, and this one is plus or minus V. So the diode will be in the off state. So diode will be in the off state, because This overall voltage having the same resistance and different voltages, but this voltage is 4.5 volt is greater than 2.5 volt. So this diode will be, so this is somehow think like this. This one is 2.5, 4.5. Okay, having the same resistance. Okay, I'm not writing. So this diode will be in the off condition. So diode will be in the off condition. So the current will be zero. It is open circuited. Okay, diode will be open circuited. So if we redraw the circuit, a very simple thing, RTH2, VTH2, VTH1. Okay, this will be, but this voltage will be plus or minus V. And then after means we have to apply KVL in this loop. Okay, so if we apply KVL in this loop, what we can write, as I am writing, VTH2, current will be 0, so no need to worry. This will be always 0, 0, minus V minus VTH1. Okay, means simply VTH2. Okay, I'm writing from VTH2 minus V minus this. So we have to write V equals to V Thevenin 2 minus VTH1. Okay, so VTH2 we have already calculated. It is our 2.5 volt. This voltage is 2.5 volt, and another one VTH1 is 4.5 volt. So it should be minus 2 volt. So the answer, correct answer for this question means the B value will be minus 2.5 volt, and diode is open, okay, or off. So this current will be always 0, and this voltage will be 2 volt. So this is all about this question. So we have to be very careful about this simple network concept of Thevenin. So it is clearly mentioned we have to do this problem with the help of Thevenin theorem. So this is all about this circuit. So thank you for watching this video.